Hello, my name is Shao, and I will be presenting my poster on Inq-ITS, Developing Microworlds for Virtual Simulation Learning. I had the pleasure of working with Dr. Janice Gobert from the Graduate School of Education of Rutgers this summer of 2021. My project focuses on creating and developing science inquiry labs for middle school students depending on the certain aspects that are related to the sciences. Inq-ITS is a science-based inquiry program used in classrooms that allows teachers to provide their students virtual learning laboratory experiences. Inq-ITS produces its laboratories through the verified Next Generation Science Standards, NGSS, giving science outcomes and expectations for students to adapt. Within Inq-ITS, students conduct experiments by manipulating multiple variables within the laboratories to understand their results on the screens. Afterwards, they analyze the result and create hypotheses, claims, and reasonings based on the results, which is inquiry-based learning. This displays these students comprehending the science concepts of the virtual laboratory and practicing the scientific knowledge that demonstrates through inquiry. Within Inq-ITS, we have added pre- and post-assessment questions that gauge the students' understanding of the laboratory before and after. These questions are designed based on the laboratory itself to display their current knowledge of the sciences. Depending on their correctness rate, this is further analyzed on whether students are comprehensive of the material or if they're looking at on false positive. Inq-ITS is an excellent tool for students to use the science process to learn through inquiry, allowing inquiry-based learning to be more effective than traditional style learning methods. That was my abstract, where I will be focusing on majority of the summer creating the pre and post questions to be further analyzed on how students are understanding and obtaining the curriculum goals of the science that they are focusing on. This summer, I was able to create questions focused on physics related to Newton's second law and momentum. So, moving on, what is Inq-ITS and how does everything work? So as we can move on to the introduction, in these two pictures, we can see that students formulate a hypothesis based on the scientific goal at hand, and then afterwards, students will run several trials to gather data that will help answer their questions. And finally, students state a claim based on their findings and indicate which evidence would support it. So for example, if one of the labs I am working on is Newton's second law, we would create a lab based on Newton's second law. And from there, these students will be able to run test trials and figure out what Newton's second law is and how the trials and the results that they obtain relate to Newton's second law. Afterwards, in this second picture, this is where students write their claim, evidence, and reasoning to fully kind of comprehend how well they understood the lab. So they would write their claim based off the knowledge that they found. Their evidence would come up next, and then their evidence is gathered from the test trial they did, and then based off of the evidence, then they put a reasoning together. So after they get the claim and evidence, they try to figure out, well, how does this all make sense and why is this the reasoning behind it? Through Dr. Gobert, using the virtual learning system Inq-ITS, Inquiry Intelligent Tutoring System enables students to be in a productive online educational setting for their science where they control their learning as found by Gobert 2000. So my methods moving on are, so what we want to do is students can be accessed by pre and post questions pertaining to each science subject. So as I said, I worked with momentum this summer, so we were creating questions based off momentum and Newton's second law. Pre and post questions have been developed in conservation of momentum questions to gauge students' understanding of the topics before completing the Inq-ITS lab. And then the last bullet point is analyze the performance rate of students using the percentages of correct answers from pre and post questions. So basically, in summary, pre-question correct, post-question incorrect, right? That basically means it's a false positive. So students were guessing on the first pre-question, and then after completing the lab where they didn't really understood the lab, they kind of just guessed for the post-question answer. It's a false positive because they were not understanding of the lab. If it's a pre-question correct and a pre-question correct, If it's a pre-question correct and a post-question correct, I apologize for that, it is a true positive. That basically means the student understood the lab, understood the questions before completing the lab, and the lab was able to reinforce their learning goals. So it's a true positive. If the pre-question was incorrect and the post-question was correct, that means the learning objectives were met. So for example, if students were not able to understand the pre-question assessment before the lab and they answered the post questions correct after the lab, that means that they actually learned what the lab had to teach them, which allows us to analyze the learning objectives as met. And then pre-question incorrect and post-question incorrect means that learning objectives were not met and that students did not understand what to comprehend of the lab itself. And lastly, these are some questions that we were able to create for pre and post. When we create our pre and post questions, we do not want them to be too different as they are still trying to get one part of the learning goal. So, law of conservation of momentum is related to which law of Newton's motion? So the answer is Newton's third law. So then the post question would be, which of the Newton's laws of motion is closely related to the law of conservation of momentum? As you can see, these questions are very similar in writing, but the reason is we are not here to trick the students, but gauge their understanding of their lab after the completion of it. And then below we have another similar question. This is an example of conservation of momentum. 1. Air-filled balloons. That's the answer. The second one is, the post question is, which of the below is an example of conservation of momentum? And again, the answer is 4, balloons filled with air. So as you can see, these answers are very similar and these questions are very similar, hence why we want to gauge their understanding. However, during this summer, we were not able to completely establish the results of our pre and post assessment questions. So results have not been established as of this moment, and we will have to test students further in the future to understand and gauge their learning of the laboratories themselves. However, we do know that from previous Inq-ITS, the majority of students are able to fit on the spectrum of learning from the lab and being able to answer the post question correctly, which shows that they are understanding the labs. The results in the future will show that the performance on the exams will be analyzed to see the benefit of the overall Inq-ITS system in the physicses. And here are some references by Gobert and Buckley in 2000, The Introduction to Model-Based Teaching and Learning in Science Education, Garcia and Weiss in 2020, How COVID-19 and Student Performance Equity in U.S. Education Policies, Lessons from the Pre-Pandemic Research to Inform Relief, Recovery, and Rebuilding. These references were able to help me create my scientific poster as it showed the need for inquiry-based learning versus traditional-based learning, where these pre and post assessment questions are able to help students understand the benefits of inquiry-based learning. And lastly, I would like to do my acknowledgements where I want to acknowledge DRC and Project Super for this amazing opportunity to be immersed in research. In addition, I want to thank Dr. Janice Gobert for having me partake in her research lab. Lastly, I would be remiss if I did not thank the Project Super faculty and research partners for guiding me through this virtual research. Thank you so much.